So welcome, officially, it is 10 o'clock. Welcome to our HIOKI webinar about efficiency management, or more precise, or specifically about how to optimize energy efficiency with current mapping is a very interesting topic today. Presenter today will be Velizara Lidoro. She will be one talking you through the different aspects on how to, what for, why it is important to do precise current mapping. And we also have Jutta here, our application engineer, who will be supporting during the course, especially during the Q&A part, when there's tricky questions coming up where both of the experts can help you with. So my part is only a very quick one to introduce the two and get you started with the webinar in total. So we think that the webinar will take 30 to 40 minutes approximately. All of you as participants will be muted throughout the webinar. However, we are very much looking forward to get a lot of questions. If you have questions, please type them into the Q&A function, or Frage und Antwort, F and R, whatever is written in your language down in the taskbar of the Zoom window. Please type in your questions there. Also during the presentation, that's fine. We will pick up the questions at the end after Velizara finished her slides. Remaining questions that we cannot follow up, that we cannot answer that, or we have to do maybe some additional research and add some more context to that, we follow up by email, as well as with the recording of this webinar, so you can recap all the content later on when you share with your colleagues or you want to take another look. Okay, so this is how we organize today's session. And with that said, I and Jutta also will go in the background and leave the stage for Velizara so she can introduce the topic to you. So Velizara, up to you.
Thank you very much, Oliver. For those of you who don't know me, first of all, welcome. And my name is Velizara, and I am the product manager for the data acquisition devices at HIOKI Europe. And I'm very happy to be able to talk to you today. Thank you already for joining. I hope I can keep you entertained for the next 20 minutes so you can see the whole webinar. I will be talking about current mapping and how current mapping can help you optimize the energy efficiency of your products, systems, and maybe even processes. Shortly on the structure of the webinar, I will talk first about what is current mapping, what kind of data or what kind of information you can get from a current map, and how you can use this information to optimize the energy efficiency of your products. I will give you two examples, one a bit of a more general example on electrical products and one more detailed example. And then I will go to the challenges, because if you want to create a current map, you need proper equipment to do so. And there you will, meet a few challenges that on the way. And I will go through these also step by step. And then, of course, I won't be talking to you today if we did not have a solution for your problems with our data logger LR8450-01, with new current modules, and of course with our huge variety of current sensors. So let's start with the big question. What is current mapping actually? So probably most of you have heard about engine mapping or temperature mapping. So I'm pretty sure most of you already guessed that current mapping is the ability to precisely identify the current consumption of components or subsystems in various operating states within a system. To put that simply, if you have a product, you want to know which components consume how much energy or how much current they consume in every different state. And by identifying these components and their consumption, you can get very valuable information, or you can analyze this information, and you can, for example, identify consumption patterns. This is especially important if we're looking at high demand periods or peak load conditions. In such cases, you are able to pinpoint exactly which components consume excessive amounts of energy, and then you can work on optimizing or re-engineering these components. Another thing that you can do is you can, of course, detect inefficiencies of components. So you're measuring the current consumption of different components, for example, in idle state or under light loads, or when it's working at full capacity. And then you can see how efficiently these components are working in these different states. And you can also detect parasitic or find parasitic energy consumers. For those of you who don't know what parasitic energy consumers are, these are components or systems or subsystems which consume energy despite being in an off or standby mode. I am pretty sure everyone's already thinking about their household and their appliances in the household. Yes, we have a lot of parasitic consumers also at home, but this is also valid for products. So if you imagine a single product, there is a lot of components inside, and there are a lot of components which are most of the time in off mode or in standby mode, but they still consume some energy. And this energy could seem at first glance very small or minor, but if you add all these components, in the end, it can have a very significant impact on the overall consumption of the whole product. And specifically for this point, I will come back to it later on, because this is something that is very difficult to measure, because we're talking about very low consumption. And for this, you need equipment that has the corresponding high precision. And the last point is, of course, current mapping can help you ensure that you comply with energy standards. So there are a lot of regulations, especially for manufacturing companies, looking specifically into consumer electronics, automotive systems, but also industrial equipment. There are regulations on the energy efficiency of those products. That's one side of the story. But of course, a lot of manufacturers are also looking into optimizing the energy efficiency, because it reduces their carbon footprint in general, and it's a good image for the company, but also for their products. Now, you have collected all this information, you have analyzed the current map, and you now know where or maybe what kind of problems you could have in your system and where you can optimize. And what you can do is, for example, you can implement more efficient control strategies or create new algorithms. For example, you can create automatic power off modes or smart energy modes. Such features are not only helpful to reduce the consumption, but also they're very user-friendly. So they're making the product also attractive to customers. Here, I would also like to give one example from the automotive part. For example, in electric vehicles, the heating, ventilation, and air conditioning is one of the major consumers, energy consumers, and EV developers are now looking into reducing the consumption in optimizing the thermal control system. And by measuring the current and the temperature within the electric vehicle, they can pinpoint which components dissipate, so emit heat, and try to use this wasted heat and bring it back into the system. So we're talking about heat recovery here. So this could also be something that could be used as an efficient control for the thermal management of a system. Of course, there are more straightforward solutions like redesigning or replacing inefficient components, also possible. And of course, you want to know how the current is carried from A to B, if that's also efficient. So you can also look into redesigning circuits and wiring within the system. The final goal is to create more environmentally and user-friendly products, which have higher sales potential in the end. And I promised to give you a few examples. I would start with a bit more general example on the reduction of emissions from electrical products. And here you can see a very nice graph I got from the EPA, which shows the total emissions of a manufacturing company. And here you can see that they split these into three major categories. So Scope 1, Scope 2, and Scope 3 emissions. And today I will talk more about the Scope 3 emissions. And the reason is these represent, in most companies, 70 to 95% of the total emissions. And these companies or manufacturing companies in general are looking into increasing the energy efficiency, achieving their sustainability goals, reducing carbon footprint. So these are topics everyone has heard nowadays. And they could use equipment to measure the current consumption or the energy consumption within their company in different ways. One thing they could do is they could optimize the energy efficiency of the products they sell. Because maybe as a background information, if a company produces products, the emissions that are emitted over the complete life cycle of this product will be counted as emissions within the manufacturing company's emissions. So they're a part of that. So this could be one thing that they can do, or one activity they can do, is to try to make their own products more efficient. But there is also another point that is quite big. So there are a lot of products they use in their processes or in their manufacturing process, but also within their products. And they could also look to use more efficient products when they know. Of course, for this, they need to know how efficient are the products that are being used. And this, of course, is creating also pressure on their product suppliers on the other hand. And the second example goes into more detail, and I already shortly mentioned the heating, ventilation, air conditioning inside an electric vehicle as one of the major consumers within an electric vehicle. But there are also other big consumers like the steering system, for example. There are, of course, the big consumers, but you have also a huge number of very small consumers. I suppose everyone almost nowadays owns a car. So you can imagine we have the interior lights, we have the lights, we have the blinkers, we have the windows, the wipers. So these are generally consumers with very low energy levels. And also on top of that, these are most of the time in kind of a standby mode. So we have a huge variety of consumers which consume low amounts of energy, but their sum in the end can have a significant impact on the consumption. So they could drain the battery and thus reduce the driving range. And EV developers nowadays are still looking into, that's actually one of the major topics, is how to extend the driving range. So by creating a current map, they can pinpoint which components are consuming a lot of energy, and then try to optimize those. I already mentioned that, you need proper equipment to create a current map of your product or of your system. And to do so, you will see that you will meet quite a few challenges on the way. The first problem that you will find is that it is very difficult to find one device which is capable of measuring low currents and high currents at the same time. So in that case, you will need to deal with multiple devices. What that means is that you need to be able to control those. So you need an automation system. You need to synchronize them. You will get a lot of different data files, probably also in different data formats. So it becomes kind of a mess. But that would be the first challenge. And let's assume you have found one instrument which can handle the high and the low current simultaneously. Then you are going to find a second challenge. If an instrument often can measure very high currents, it becomes inaccurate in the lower ranges. And this is going to be especially a difficult point looking into these low energy consumers or the parasitic consumers within the product. Of course, you are going to be measuring also into systems which are at least partially, if not fully assembled. So this means space will be a big issue, and bringing the equipment within these tight spaces is also going to be quite a challenge that you will have to deal with. And if you have measurement equipment, I am not sure, I will try to explain it shortly, but so first thing that you have to be careful about is you're not going to do a test over 5 minutes, obviously. So it's going to be a test that will run for longer time periods. So you need to make sure that your equipment does not drift. So you need a stable measurement over longer time periods without the need to stop the measurement in order to do adjustments, calibrations, or similar. The second thing is that measurement equipment is usually affected by temperature. This means that if your laboratory is not air conditioned and the temperature in the morning is low and in the evening or over the day it rises, then you may need to recalibrate or do a zero adjustment of the equipment. Otherwise, you also may see difference in the readings. That's the second. And of course, a nice thing is if you have products which you want to test at more extreme temperatures, then you would like to have equipment which can also obviously handle these extreme temperature conditions. And last but not least, of course, we live in a moving world and everyone wants to do everything remotely and autonomously. So in the best case scenario, you have equipment that does not need any power supply. You can carry it around. It can send you the data via wireless LAN or Bluetooth. So this is also something that you could, it's not a must, but it's a nice to have feature. And in some cases, it is very helpful, especially looking back again at automotive, and the measurement onboard testing, of course, is now the standard. Yeah, I told you that we do have a solution for the problem, and this solution starts with our data logger LR8450-01. The -01 stands for the wireless version, so we have a version that works only with plug-in modules and one that works with wireless modules. This data logger, on the data logger, you can configure different settings. But what you can also do is you can also visualize or display the data in real time on the LCD display of the data logger. But to collect or to record data, you will need also some modules. And for current measurement, we have two different types of modules. We have a plugin module type, which you can simply plug in on top of the module. So you can stack up to 4, so 2 and 2 modules on top of the data logger. And we have a wireless current module, which which collects the data and transfers it via wireless LAN for a distance of up to 30 meters. And you can connect up to 7 of these wireless modules. So you can use a combination of both, 7 plus 4, so 11 modules in total you can connect to the data logger. And each one of these has 5 channels, which means that you can log in total 55 current channels with a single device. Of course, the modules are recognized automatically by the data logger, and this is also valid for the current sensors, which are compatible with this combination of data logger with current modules. And we have, I think a variety of current sensors, which covers probably all applications, going from 2 ampere with the CT7812 and going up to 6,000 ampere, for example, with the Rogowski coils. Now, I was talking a bit about these low energy consumers and parasitic consumers, and that this is a very difficult point, that these are difficult to measure because you need very equipment that has very high precision specifically for these low values. And that's why I would like to go into a bit more detail about these two current sensors that we have. We just launched beginning of this year with a rating of 2 ampere and 20 ampere. They have very high accuracy of 0.3% and a minimum resolution of 0.1 milliampere. This means that you're able to capture currents as small as 100 microampere. So they are specifically made for the measurement of low currents. And besides that, you can install them practically anywhere. So you can see a very nice here, a very nice picture, which gives you an idea how small they are. These, for those of you who already know the HIOKI current sensors, these are the CT6841A current sensors with 20 ampere rating. And here you can see that the new current sensors are much smaller. And to put that in numbers, they are volume-wise 10 times smaller and just below 8 centimeters in length. They also have another advantage for the installation, which is you cannot see here on the picture. To open them, they have a slide back mechanism. So the other clamps that we usually have, they have a jaw which opens, so you need even more space to connect. And these you just slide back, and then you can connect it to the cable of the consumer. Yeah, they also work from Alaska to Sahara. What that means is you can use these sensors in temperatures between -40 and +85 degrees, and not at a fixed temperature, but they are temperature compensated, which is also, by the way, valid for all the other current sensors which work with this solution, which I just shown in the last slide. So they are temperature compensated, which means even if the temperature within your laboratory or test facility is changing, you will not see any issue with the measurement. And what that means is that you can measure over longer time periods. We have ultra low drift because the sensors also use the flux gate technology. And I have a very not much saying diagram, but I will explain it and then you will see it says a lot. And namely, you can see here on the y-axis our specification with 0.3% basic accuracy. And you can see we have run a measurement with 3 current sensors to have the mathematical average. And we have done the measurement for almost 8 hours. And what you can see is that there is barely any change. I still put some effort to calculate this change for you. By the way, for those of you who are interested, this is measurement of 2 ampere at 55 hertz. And you can see that there is maybe, if you look very closely, a small deviation here, small drift. Let's put it this way, but the peak-to-peak deviation is 0.001% of reading. So it's very low. Just to give you also some additional information, if you're more interested, or if you're interested to get more information on that topic, we will have, or where I got also this data from, and not only this data, I got some more data, but we will have soon a technical paper on the performance of these sensors. So I cannot tell you exactly when, but it should come out in the next few weeks. And there you can enjoy a lot of such diagrams and some more background data. And then, you can get a better idea about the performance of the sensors. The last point I mentioned, or the last challenge I mentioned, was the autonomous operation and the remote working modes. So the data logger and the modules can operate on batteries. This means we have the possibility to have a power supply, of course, but you can also use batteries. You can fit 2 battery packs inside the logger and 1 inside the wireless module. And coming to the wireless capability, you can see here in the picture, you can install the wireless module very close to your DUT and measure and send the data via wireless LAN to the data logger, so you can work remotely and without the need of having any power supply. And I already spoke also about the heat recovery and measuring the temperature and the current consumption in order to optimize the thermal control of electric vehicles. In these cases, you will also need to measure temperatures, obviously. And by the way, a pro tip would be you could also measure heat flow if you're not sure where your which components are dissipating heat. You can use heat flow measurement, which gives you also the direction from which the heat is coming, and not only the temperature, but you could also use temperature sensors like thermocouples or RTDs like PT100. And for that, you can connect a variety of other modules to the data logger. You could use the analog, so voltage temperature modules to measure the temperature or the heat flow in that sense. You could also, so we have a selection of 7 different types of modules in total, so 7 plug-in plus 7 wireless modules. And there is a variety of parameters that you can measure practically. So you can mix and match the modules in accordance with your test requirements. You're completely free to do so. And for example, if you take the 30-channel module that we have, and you can have, in that case, up to 330 channels. And to close the presentation, I would like to say that optimizing the energy efficiency of products and systems, or even processes, by the use of a current map can be an easy task if you have the right tools in your hands. And before I go, if you have any questions, you can ask them now. But as Oliver already mentioned, you can also contact us, of course, anytime. For technical questions, please feel free to contact PM support at hioki.eu. Mostly it will be me answering the questions, but if I'm on vacation or out of office, my colleagues will take over. And for other inquiries, please contact HIOKI at hioki.eu. And thank you for joining the webinar. And I'm really eager to hear the questions from Yuta. I hope we'll come back online. Yeah.
Yes, thank you.
Perfect. Thank you, Yuta.
Okay, we move to QA sessions. So we have some questions. I will pick up some questions. So the first one is which current sensor? The question is the current time. What is a suitable current sensors? The which current sensor do we have that can manage these low operating current and still like survive operating current? We already introduced new current sensors, but we have two current sensors, maximum 2 and maximum 20 amperes.
Yeah.
Which current sensor is suitable for this like very small current measurement and also like survive or like operating the loading current situation?
Yeah, well, it depends how high the current is. So the new current sensors offer 2 ranges each, so they have very high accuracy. If you take the 2 ampere rated current sensor, CT7812, then you have a 200 milliampere and 2 ampere range, so 2 ranges in total. And the other sensor, the CT7822, has also 2 ranges with 2 ampere and 20 ampere. So it's you can pick one. And what I forgot also to mention, I'm not sure, probably I mentioned it. You can, if you have also high currents, you can just mix and match the current sensor. So you're not, you're not limited to connecting the same sensor 5 times to one module. You can just take different sensors.
Okay, you mean the error rate 450 can adjust for the like you can choose the like suitable sensor for each like DUTs or like power consumptions. Okay, thank you. Wait. Okay, we move to second questions. The question is how accurate we introduce for like a load lift or this kind of thing, but also the accuracy or accurate is also important.
Yes.
How accurate is current measurement when logging across like multiple channels and with both high and low current measurement?
Well, the total accuracy is practically the sum of the accuracy of the current sensor plus the accuracy of the modules. I can provide information. We will send an Excel file probably with a Q&A afterwards, so I can dig out the information, because of course I don't know the numbers. I don't have them all in my head. But if you connect, for example, the CT7812, which has 0.3% accuracy of the current sensors, then you have to add the accuracy of the module, and it's the same calculation practically for the other sensors. So if you have a current sensor with 1% accuracy plus the accuracy of the module, that would give you the total accuracy of the system, or for the measurement of that current, because it depends always on the current sensor.
Okay, thank you. But at least the new current sensor CT7812 is so basic accuracy is 0.3%. It's quite accurate for this kind of small measurement. Okay, thank you. Okay, well, so we have a different question. Okay, we have a question. So I just read the question. So can the wireless module be used with any tool that can capture the wireless signal?
That's a good question.
Yes, and then what if the current is over 0.2 or set the
Overrange.
overrange during the operation. Do you then have to use for the high range, or will the low current units survive the overcurrent? So, which means probably the robbers can adjust for the level of the current, or we should set for the fixed range.
No, it is a fixed range. So I will start with this question. So it is a fixed range. So if you select, for example, if you have a 20 ampere current sensor and it has 2 ampere and 20 ampere range, you select the range. And if it is over 2 ampere, you will see a flat line. So it will be just cut off. This means that you have to consider measuring. So there is no auto range switching. So you have to consider before starting measurement which range you will require. And regarding the wireless modules, it is not possible. So the wireless modules can only communicate with the data logger. But you have the wireless capability of the logger itself. And instead of using the wire, if you're not using the wireless modules, but you are just using plug-in modules, you can, for example, use this wireless capability to connect the logger into your internal Wi-Fi network. And you can, collect data or, also control and see in real time the data logger over the Wi-Fi network on your PC, for example.
Okay, thank you. Okay, we move to the logger's general question. The logger can measure long-term data, and then as you explained for me, for example, the LR8450 can connect with a PC, and we can store the data in the PC. And then but the LR8450, how does the LR8450 handle the long-term data storage for in the loggers or the PCs, and then how to analyze for this kind of extended testing?
So you have several possibilities for data storage. You can take a look also at the website. So we have an SD card storage. You can connect USB stick. You can also connect via LAN, and via LAN you can also control and transfer data. We also have a software that you can use by connecting either via USB or LAN to the device. It's the Logger utility software, which you can also download for free. And then you can also connect up to 5 data loggers for the same software, and then display all their data. In the software, up to 600 channels in real time you can display. So those are the possibilities, I'd say. And you can transfer also data via FTP and so on. So it's all possible.
Okay. So basically, the LR8450 have some store functionality, and also the LR8450 can communicate with a PC with this kind of things, and then also the LR8450 can store in the PC or pick up the data from the data loggers. Okay.
Yes.
Thank you.
Perfect.
Okay. We have another question. The question is regarding the wireless module. What distance that the wireless module can communicate with a logger? What is the maximum distance between a logger and the wireless the module?
That really depends on the installation situation. We say 30 meters visual distance, but if you have a wall or some casing around the wireless module, this distance could become shorter. It's a Wi-Fi signal in the end. So it's a normal thing, like with your cell phone. I'm pretty sure you also know that it doesn't always have very good connection. So that's very... but visual distance would be 30 meters.
Okay, so you mean the 30 meter is a bit like a maximum distance between the logger and the modules, and then and normally there's some walls or cases, or there's some not good communication environment, and in this case, probably
Isolators.
in this case, probably the distance would be shorter than like 30, maximum 30 minutes, 30 meters. Okay. Okay, thank you. Okay. Okay, so and I move to a different kind of questions. So logger is so basically the long-term measurement devices.
Yeah.
And then what kind of maintenance does a data logger require? Is there any like a regular calibration or so this kind of like inspection is required or not?
Nothing is required in our world, luckily, but we recommend to send back the modules. So the logger itself does not need recalibration because it is just collecting the information and visualizing the information. But we recommend you to send the modules for adjustment and also the current sensors if you're using those. You can send them back once per year and we can calibrate and do adjustment if necessary.
Okay, thank you. But especially for the current sensor, it's quite like accurate and also like high resolution. It's quite like a high sensitive like sensors. So you mean we would recommend to at least the current sensor should be calibrated a year or so. The regular is okay.
Yeah.
Okay, thank you. So we have another few questions. Okay. One thing, it's a bit like a general question, or it's a bit like our side questions. So the like a trial of this unit. So do you offer a trial or like do we have the demo unit to trial for checking this kind of like new applications?
Yeah. So we do have in our company, we have 3 demo units, which we can book. We typically can give them for 2 to 3 weeks. Or as a demonstration, they have, by the way, not only the current modules, but they have also the full equipped solution with all the modules. So you have 14 modules that you can select from, so you can test all combinations. If you want for current sensing, then we should discuss in more detail which current sensors, but we can provide complete solutions as demonstrations for 2 to 3 weeks.
Okay, thank you. Okay, thank you. And then, okay, so I pick up the different kind of questions, especially for the like software and the remote monitoring or analyzing. So the error rate for 50, especially for like the -01, work with external software for remote monitoring and analysis.
Yeah, I already mentioned that before. We do have this software tool which is free of charge to download from the website, but you can also directly connect via LAN to your PC, and you can. It's a bit difficult to explain. So you type in the IP address in your internet browser, and then you can see the data logger, the digital version of the logger. So you can control it. You can collect data. So it's a very nice tool also without really actively using a software for that. You can just connect via the browser, and then you can control the logger and see the measurement data on a bigger screen.
Okay.
So there are these 2 possibilities practically. Sorry, not 2, 3. I forgot Genect 1. Of course, you can also use Genect 1 if you have more HIOKI devices. I'm always fixed on the data loggers because those are my babies practically. But if you're using also other HIOKI equipment, you can also connect the data logger to Genect One to monitor data on it.
Okay, so which means so basically we have like two free software for analysis and data collecting.
Yeah.
And also the LR8450 have a provided option, for example, CSV or other like
Sure.
general like file format. And then so which means that you can analyze by Excel or this kind of normal site. And also that we have some like free software and you can use the collecting and analysis. So we have like main two options.
And we do have also some drivers for third-party softwares like LabVIEW, for example. You can also, we do not actively support them, but we do have drivers. So if you want, you can operate also with third-party software. It's also possible.
Okay.
Yeah.
Thank you. So, okay, now we have few minutes, and okay. The next question is, how easily can I expand my setup if I need to add more channels or measure different parameters in the future?
Mm-hmm. Very easy. You just buy another module, so it's really very simple. There's not much you can do. You just buy a new module, and then you can directly connect it. If it's a plugin module, then you directly click it on the data logger on top. Or if you have a wireless module, you have to connect the wireless module, but it's a very straightforward. You can also do it on a daily basis, just switch modules for the task on hand, so you don't have to always connect a full setup and have too many channels, and so you can always pick exactly the modules you need, and if you want more, then you can always extend, of course, with the limitation maximum 4 plugin plus 7 wireless, so in total 11 modules you can connect.
Okay.
Yeah.
But at least for example, the LR8450, the customer don't need to purchase the new one with when the launching the new modules. So which means probably the LR8450, if you have LR8450, and then we or HIOKI provide the new modules or new sensors or new applications, just like purchase the new module or new applications, the product, and then just connect it and then you can use it.
And you need an update. So if you have an older module, obviously you need to update the firmware, which is also, you can download from the website, but then you can directly use the new modules.
Okay.
Yeah.
But just like a software update is required, and then you don't need to purchase a new LR8450.
No.
Yeah. Okay.
Except if you've reached the limits of the LR8450, then you can purchase a second one, and you can synchronize them if you want to use more loggers.
Okay.
Oliver is back online. This means I think he wants us to come to an end.
Well, I'm really happy that we answered so many questions. Unless you have another one that we really can go over. But to me, at least, I understand that it's a very flexible data logger solution that we have here. Our main topic today, however, was the current mapping, the current measurement solution, because it's new for our logging system, and also new, especially in combination with the ultra compact, with the new sensors that we have, even to collect up to very low, very small currents. So that was the one, but also we learned just with this last question that it's very flexible and you can expand it in whatever direction is your requirement, or if you have several different applications, you can also easily adapt it to a different application for measurements. Yeah. And I think also that what is important that for me to take away that although we had 2-3 times we were going over, that it's a very practical application for the automotive industry. Of course, this applies to all complex systems where several current users, current consumers are in place to evaluate our systems, right? So from home appliances to whatever you can imagine. Okay. Yes, all right. Thank you very much. Thanks a lot for, I think, the in-depth introduction of the current mapping solution specifically, but also the variation of logging and measurement data that you can handle with the LA8450 and its different modules. Thank you, Velizara, for the presentation. It was really a very, very good introduction to that field. Thanks, Jutta, also for backing up and following with the questions. And thanks, everybody, for joining this webinar. Again, we will share the information after the webinar, so you can read there. If you find then questions or just after switching off your application, please send us an email, and we will get back to you as quickly as possible. All right? So Thank you very much.
Thank you.
Thank you.
Thank you.
And
Bye.
See you soon. Bye.
Bye.
Bye.